All right, so here's the lesson for today. All right, so mixed review. All right, so if you look at these first few, there's a couple of them I just gave you the answer because I'm gonna expect you to do it yourself. All right, but let's look at these. When you're doing these types of problems, remember, think about just cross multiplying. All right, so we can make this thing a fraction by putting a one underneath it, and we're gonna cross multiply. All right, so you remember doing this thing. So we're going to multiply -6. All right, we're going to multiply that -6 to both the x and the -5. We're multiplying it to both of those. All right, so that's the thing I want you to remember. All right, so we're multiplying to both of those. We end up with -6x plus 30 is equal to, and now we cross multiply the other way. All right, well, 1 times 1 just gives us 1. Solve just like you've always done. All right, so you're going to subtract 30 from both sides. -6x is equal to -29. Divide both sides by -6. X is equal to, since both of them are negative, it's going to become a positive. 29 over 6 can't be reduced down any further. Or for you guys that absolutely hate fractions, x is approximately equal to, well, not in this case, it was actually an exact answer, is 4.83, and that 3 is repeating. All right, so you got the answer for 2 and 3. Number 4, same thing. All right, I'm just going to go a little bit quicker through this one. When you multiply this, again, cross multiply, cross multiply. All right, doesn't matter which one you do first. The reason why I'm going to pick doing 8 first is because when I look at 8 times y, all right, when I look at that 8 times y, it's bigger than 7. All right, that's 7 times that y. So I want the bigger number on the left side. Since I have control of it, I'm going to do it the way I want to. All right, we have 8y minus 8 times that -3 gives me 24 is equal to. Now I'm going to do this 7 times this one. 7y plus 21. Again, it could have been flip-flopped. It doesn't matter. I just chose to have that 8, the bigger number, on the left side. So I subtract 7y from both sides. I end up with y minus 24 is equal to, that goes away, equal to 21. Add 24 to both sides. So I end up with y is equal to 45. And remember, you can always check your answers. You can always check your answers by plugging this mess back in. 8 over 45 plus 3, it better equal 7 over 45 minus 3. All right, those two things better equal. They better be the same. So when you're done with this problem, the two fractions better equal. All right, I'll let you guys check that. Number 5. All right, so we're still solving. You'll notice the thing we're solving for, that p, is underneath the radical. It's underneath the square root symbol. So the first thing we have to do is we have to get rid of that 2. All right, so let's get rid of this 2. Subtract 2 from both sides. So that goes away. I'm left with the square root of 80p plus 1 is equal to 9. And then, how do I get rid of that square root? Well, to get rid of the square root, I'm going to square both sides. The squared and the square root cancel each other out. So what I'm left with is everything underneath the radical. Everything that's underneath the square root is what I'm left with. And then 81. All right, so I squared both sides. Now, just like always, subtract 1. All right, just like you always have solved, divide both sides by 80. P is equal to 1. All right. So just remember, with these types of problems, when you have a square root, there's actually a little invisible 2 sitting there, right? It's not invisible, but people are lazy. They don't want to write it. So when you look at this problem, number 6, there's actually a 3 sitting there. So what do I have to do? I have to raise everything to the third power. And the thing that's going to be left, all right, the thing that's going to be left is what's underneath the radical. So we end up with x minus 6 is equal to negative 2 to the third power. It's negative 8. Add 6 to both sides. X is equal to negative 2. And again, how can I check this? All right, I didn't do it with number 5, but with number 6, how could we check this? Plug it in. The third root of negative 2 minus 6, it better equal negative 2. So the third root of negative 8, again, it better equal negative 2. Well, the third root of negative 8 is negative 2. All right. So if you're trying to remember how to type this onto your calculator, all right? So a quick reminder on your calculator. You're going to hit second and you're looking, right? You're looking for that key right there. Right? You're looking for that key. So since we had a 3 sitting up here, since I have a 3 sitting up there, I have to put the 3 out in front. So then you hit the second, and then you find that button. All right, you find that square root button with the X in it, and then type in negative 8. And when you hit it, it should give you negative 2. All right, so just a quick reminder on your calculator. All right, these problems you're solving. All right, I'm not going to do all of them for you, but you'll see number 7. There's the answer. All right, again, if you have a hard time, please email one of your teachers for, all right, help, and we'll try to help you out. Number 8. All right, this was an ugly one, so I figured, all right, this one I will help you with. The very first thing I'm imagining everybody has noticed is that 1/3. Well, how do I get rid of that fraction? I'm going to multiply both sides by 3. Right? And what happens is that 3 and that 3 will cancel. So I'm left with 3a is equal to m times the quantity q plus k. All right, so the fraction's gone away by multiplying by the denominator. Now, I could distribute, but that makes too much work. And you guys know I'm lazy. So distributing means multiplication. Well, what happens if I just divide both sides by m? Those cancel. So I have 3a over m is equal to q plus k. And we're solving for q. Almost forgot what we were solving for. All right, so we're solving for q. So that means I have to get rid of the k. So I'm subtracting k from both sides. So it's just going to be 3a over m minus k is equal to q. All right. Number 9. I'm just going to start it for you, but I'm not going to finish it. Number 9, since we're solving for x, you'll notice there's an x in both of those. All right, so the thing I'm going to want to do is I want to factor that x out. So I have u is equal to, I can factor out the x from both of them, k plus y. All right, now if you look up here, if you look at number 8, it's exactly the same from that step. All right, you guys finish it. All right, I'll give you the answer. X ends up equaling u over k plus y. All right. Number 10. We're solving for L. L is stuck underneath the radical. It's stuck underneath that square root. So the thing I want to do is let me get rid of that mess first, right? Let me get rid of it. So I can just concentrate on that square root of L over G. Well, when we do this, right, when we're doing these type of problems, I hope you guys remember that it's 2 times pi is just a number. Right? You can grab your calculator and figure out what 2 times pi is. But regardless of that, when you have this 2 times, this number in front of this, what is that doing? We're multiplying. So how do I undo that? I'm going to divide. So I'm going to divide both sides by 2 pi. So I have t over 2 pi is equal to the square root of L over G. And again, remember, how do we get rid of that square root? Remember, think about there's a 2 there. I'm going to square both sides. All right. So on the left side, I have t squared over 4 pi squared. Because all I did was I squared each one of those. I squared each one of those individually. All right. Square each one of those individually. So t squared, 2 squared gives me 4. Pi squared is equal to L over G. All right. Now, I could cross multiply like we did over in the other problems, but if I just multiply both sides by G, L will be left by itself, which is what I'm solving for. All right. So L is equal to G times t squared over 4 pi squared. Now we're looking over here. Thing I want you guys understanding is what's being squared. Only the t is being squared, not the g. All right, only t is being squared. All right, so factoring for number 11, there's the answer. All right, that one's not too bad. Number 12. Number 12 is a pain in the butt one. All right, this is the ugly one. So if you look at all the coefficients, hopefully you'll notice that you can divide them all by 2. So I have a GCF, 2. What do I have left? 7x squared minus 30x plus 8. All right, now remember what we've done in the past with factoring. All right, so you remember the pattern. 7x, 7x, all over 7. This 2 comes along for the ride the entire time. It does not go away. If you lose it somewhere, the problem's wrong. It has to be there. All right, so now, remember, we have to multiply a times c. So a times c. So 7 times 8 gives me 56. Well, what can I multiply? I can multiply 1 times 56, 2 times 28, 4 times 14, 7 times 8. Well, which of these pair is going to give me B? All right, which one's going to give me negative 30? This one's going to give me negative 30. Sorry, that's supposed to be a 2. How do I get negative 30 out of that? Well, it ends up being negative 2 minus 28. So what happens is the 2 has to be negative and the 28 has to be negative. So negative 2 minus 28. All right, so again, I'm dragging that 2 along. All right, and this 2 just keeps getting dragged along. Now what I'm going to do is I look at all 3 of these numbers in that box. Can I divide them all by something besides 1? 1's not going to help me. No, I can't divide them all by something, so I'm just going to recopy. This 7 now is going to get moved over there. All right, same thing. I look at all 3 of those numbers. Can I divide them all by something? Yes, I can divide them all by 7. All right, so 7x divided by 7 just gives me x. Then negative 28 divided by 7 gives me negative 4. 7 divided by 7, I'm left with 1. As soon as I get 1 in the denominator, I know I'm finished. All right. 13 is prime. Don't get screwed up. All right. It might look like the difference of squares, but whoever typed this up is trying to trick you. You notice there's a plus in between. It's not a difference of squares. So this one is prime. Number 14, there's your difference of squares. All right, 15 through 17. These we're going to be solving for x. We have to figure out in this 16 and 17 is y. All right, so we're trying to figure out what the variable represents. So 15, that one should be easy enough that you should be able to factor that. Okay, 16. If you notice number 16 is kind of screwed up in a few different ways. All right, so number 16 screwed up in a few different ways. You'll notice that it's not in standard form. All right, and it does not equal 0. So we have to force these things to happen. This has to equal 0. All right, so as soon as you see y by itself, just get rid of the y and plug in and replace it with 0. Now we have to put this thing in standard form. So from the biggest exponent to the smallest one, 9p squared minus 9p minus 7. You notice the signs came along with it. All right, the positive and negatives come along with it. So I'm going to use the quadratic formula. They're telling me to round to the thousands. And the reason why I'm going to use the quadratic formula is I don't want to waste my time trying to factor it. If it can't be factored, right? If it cannot be factored, then I have to go back and use the quadratic formula again anyway. So I'd rather just cut to the chase and just use the quadratic formula to begin with. All right. So you guys remember the quadratic formula. X is equal to negative b plus or minus the square root b squared minus 4ac all over 2a. All right, now plug all that mess in. I'm not going to write a, b, and c for you guys. You guys at this point should know. So b, all right, so there's my negative, and b happens to be negative 9 plus minus the square root of negative 9 squared minus 4 times a is 9, c is negative 7. And of course, I don't have enough room. This whole thing divided by 2 times 9. All right, x is equal to positive 9 plus or minus. All I want you using your calculator for is the stuff underneath. Type in the discriminant. Do not type in the square root. So when you type that in, you end up getting 333 all over 18. Well, 333 is not a perfect square, so I'm glad I did not try to factor it. We have 9 plus or minus the square root of 33 is approximately 18.248. All right, so again, they told us to do the thousands, 3 decimal places, all over 18. All right, so now, and this probably should have been approximate because it's not exact. 9 plus 18.248 over 18, and then our other answer is approximately equal to 9 minus 18.248 over 18. Grab your calculator. Please do not type this whole thing in on your calculator. All right, do not do that because your calculator's stupid. If you type that whole thing into your calculator, if you just do 9 plus 18.248 divided by 18, what is your calculator going to do? Your calculator is going to do this calculation first. Your calculator's stupid. You have to think for it. If you're just going to type in this whole thing on your calculator, please use parentheses around this. Tell your calculator, do that stuff first, then divide by 18. All right? So, and somewhere along the line, I think I changed the variable. Yeah, I screwed up, guys. All right? Instead of x, everybody, make sure you guys know this is supposed to be p. I'm always used to putting x, all right? So that's supposed to be p is equal to, all right? Yeah, I know. Technicalities, all right? Technicalities, p is approximately equal to, all right. I knew I was going to screw that up. Okay, so then when you type all that mess into your calculator, p is approximately equal to, all right? P is approximately equal to 1.514, and on this side, negative 0.514. Okay? 17. I'm just going to set 17 up, and then I'll let you guys finish it. I'll write the answer. All right, so 17. You'll notice with 17, again, it's all screwed up. All right, remember, it has to equal 0. And in this case, there's only one variable, not like in 16 where there was a y and a p. But in 17, there's only one variable. So what we want to do is we want to force it to equal 0. All right, so we end up with 28y squared. Well, how do I move that to the other side? Change the sign. So instead of it being a negative 17y plus 17y, then I need to change this positive 3 to the other side. Now, how do I do that? Change the sign. It was a positive 3, so now it's going to be a negative 3, and force it equals 0. All right, there's your A, B, and C. When you do this one, all right, I'll give you a hint. It can be factored, but if you don't want to factor it, let me see what's the variable so I don't screw it up. If you don't want to factor and you just want to use the quadratic formula, you'll end up with y is equal to 1 over 7, or for you guys that absolutely hate fractions, 0.143 approximately, and then y is equal to negative 3 over 4, all right, or y is equal to negative 0.75. All right, so I hope that helped. Oh, here, I'm sorry, 1819. You have your find your vertex and tell me if it's a min or a max, right? Really quickly, just to remember, just really, really fast. If A is positive, the graph opens up, your vertex is going to be a minimum. If A is negative, it's going to open down, your vertex is going to be a maximum. Okay? All right, hopefully that helps.